All right, this is a recording on special right triangles. So, page 36. Now, special right triangles are 45, 45, 90, and 30, 60, 90 triangles. Now, let's start with the lesson. What is the Pythagorean theorem? Write out the formula using words leg and hypotenuse. Well, the Pythagorean theorem is really leg squared plus leg squared should equal the hypotenuse squared. Does it work for all triangles? No, it only works for right triangles. Use a protractor and ruler to sketch a 45, 45, 90 triangle with a leg length of 2 centimeters. Well, we're not going to do that. We're just going to trace a 45, 45, 90 triangle. And that looks pretty good. And that means this is a right angle. Now, they're going to say one of the leg lengths is 2 centimeters. So there's one of my legs. It's 2 centimeters. And if one of the legs is 2 centimeters and these angles are the same, excuse me, in terms they're both 45 degrees, that means it's an isosceles triangle, and these sides are congruent. So if that's 2 centimeters, then this is also 2 centimeters. So why is that? Well, you could say because these angle measures are exactly the same, therefore the distance across from them is identical. What is the name for the triangle above? It is isosceles triangle. And if two sides are congruent, then two angles are congruent. Okay. Use your ruler to measure the length of the hypotenuse. Okay, we're not going to do this. I don't know, I might do it in class, but what you would get is, I believe, 2.8 something. And write down a decimal answer to the nearest tenth of a centimeter for the length of the hypotenuse. Now, if you want to find that length using the Pythagorean theorem, you would do 2 squared plus 2 squared equals c squared, which is really 4 plus 4 equals 8. And what's the square root of 8? It is, if you plug it in, it should be 2.8. I'll check real quick, just so I don't make this mistake. Square root of 8 is 2.828. So, yes, we'll go with 2.8. Compare your estimate. Wow, our estimate from measuring with the ruler and the Pythagorean theorem is the same, okay? How could we get an exact length for the hypotenuse? Well, using the Pythagorean theorem. All right, so now we're going to find the length of the hypotenuse given a 5-inch leg, okay? So here's my 45-degree triangle. I'm going to call this 5 and this 5. Well, how would I find this answer? Well, it would be 5 squared plus 5 squared equals c squared. Well, what's 5 squared plus 5 squared? That's 50 equals c squared. Square root both sides. And what's the square root of 50? And this is what we're going to get into. So if we go back to this original problem, we did 4 plus 4 was the square root of 8. Well, can we simplify the square root of 8? I'm going to do it right here. What's this square root of 8 simplified? Well, it's 2 root 2. All right, what do you think this one's going to be? Well, what's the square root of 50 simplified? Square root of 50 is 25, 2, 5, 5. Circle the pair. It's 5 root 2. So this length out here is really 5 root 2, and I'm going to change this 2.8 up here to 2 root 2. And it's going to ask, hey, what patterns do you notice? Well, hopefully you notice that the hypotenuse is just 5 times root 2, or 2 times root 2 up here when the leg was 2. So what we could write down is a 45, 45, 90 triangle looks like this. It looks like x, x, and x root 2, because whatever x is, in this case it was 5, then it's 5 root 2. And that is a formula we could use for it. So they're giving you some Pythagorean theorem practice down here to find the missing side lengths of the triangles, and we're going to reduce it to root form. And I gave you some practice earlier in the previous page on this, but we'll do it again. 8 squared plus 15 squared is 64 plus 225, which is 289, which the square root of 289 is 17. So I guess x in this case is 17. Now if we have 2 root 3 over here and we have 6 here, it's going to be a little different. We're going to say this is the hypotenuse here, so we're going to say this is x. And we're going to say 2 root 3 squared plus x squared equals 6 squared. Well, what is 2 root 3 squared? Well, 2 squared is 4. Root 3 times root 3 is 3. Plus x squared equals 36. Well, that's 12. And if we subtract 12 from 36, we get x squared equals 24. Square root both sides, and x equals, well, what's the square root of 24 simplified? 6, 4, 2, 3, 2, 2, which is 2 root 6. Awesome. And now we have an isosceles triangle here, and we could do the Pythagorean theorem, but we just did it earlier. So what does x equal? X equals 5 root 2. If you have questions on that, you can check. Now, did we have any 45, 45, 90 triangles? Yeah, just this one over here. Okay. This one was close. It was 2 root 6 and 2 root 3, but that's not a 45, 45, 90. Okay. Find all the missing side lengths for the triangles below. Well, if this is 6 root 2, remember this was x, and this was x root 2. So what do you think x equals? 6. And now this is going to be a little tricky, because if that's x, and this is x root 2, that means 6 equals x root 2. Well, how are we going to isolate x? Well, you got to divide by root 2. Now, you might remember from an earlier lesson that we can't have a radical in the denominator. So what we're going to do is we're going to multiply, we're going to rationalize it by multiplying top and bottom by root 2. So it's going to be 6 root 2 over 2, which is what's 6 divided by 2? 3 root 2. Final answer. And this one, very similar. I think it's just the same question, so I'm not going to do this one. Just cross this out. Alrighty. This is where it gets fun. We got an equilateral triangle below. So if this is an equilateral triangle, that means this is 8, and this whole length right here is also 8. Okay? Now, one angle has been bisected with a perpendicular bisector. Bisect means to cut into 2 equal pieces, and a perpendicular bisector means these are right angles right here. Okay? So now we have split this into 2 triangles. And what do we know about an equilateral triangle? We know that all the angles on the outside are 60 degrees. So there's 60, there's 60, and this one right here is also 60, which if we split it in half means this is 30 and this is 30. All right, so we've got our hypotenuse. What is our short leg here then? Well, if this is all 8, what is this length right here? It's 4, it's half of it. Therefore, this is also 4. And if we have 2 sides now, well, how could we find the length of, so we just found the length of AD. I haven't really been following the directions here. What are the 3 angle measurements of the newly formed triangle? It's a 30, 60, 90. And what is the length of BD? BD is also 4. And use the Pythagorean theorem to find the length of CD. Well, we've got one leg, which is 4 squared. We don't know CD. That's going to be x squared in this case. And we do know the hypotenuse, which is 8 squared. So we're just going to subtract 4 squared from 8 squared, which is going to be 64 minus 16, which is 48. Square root both sides. The square root of 48 is 16, 3, 4, 4, circle the pair, x equals 4 root 3 centimeters. So that is what CD equals. What pattern do you notice in the side lengths of the 30, 60, 90 triangles? Well, compare with your partner. Well, do you see 4 root 3? So this length right here is 4 root 3. The short leg's 4. What do we know about the hypotenuse? It is double 4. 4 times 2 is 8. And the long leg, we call it right here, is going to be 4 times root 3. So if we sketch a diagram of a 30, 60, 90 triangle, this would be, they said make the short leg x, if you read the directions. The short leg is going to be x. The long leg would be x times root 3, and the hypotenuse would be 2 times the short leg, which would be 2x in this case. All right, this 30 should really be down here. That's 30 degrees. So use the above investigation to find the missing side lengths. Well, if this is 30 degrees, that means this is the short leg. Therefore, y is the long leg, so this will be 3 times root 3. And the hypotenuse is 2 times 3, which is going to be 6. So what is a rule for finding the side lengths of a 30, 60, 90 triangle in relationship to the short leg? Well, if the short leg is x, which I'll say is x, equals x, the hypotenuse is 2x, and the long leg is x root 3. Now, why are the 45, 45, 90 triangles and 30, 60, 90 triangles special? Well, they have these relationships that we can create pretty easy proportions to. They're also really common triangles, okay? So they're very common, and they have consistent proportions. And actually all triangles do, but these are just much easier to solve with. All right, moving on. You've got independent practice here, and I'm only going to do a couple of these with you, and then you're going to practice on your own. So find the missing lengths using the Pythagorean theorem. Show complete work. So on these, this should be pretty easy. You're just plugging in these values to this triangle here, and then you're finding the answer to the Pythagorean theorem, okay? And it might not necessarily look correct because all these values are going to be different, but I'll tell you right now, B is going to be 12. So if you got 12 for B, I'll just talk about the first couple. We've got C squared is 13, so that's going to be 13 squared. That's my hypotenuse, minus my leg, which is 5 squared, which is going to be 169 minus 25, which is 144, and the square root of 144 is 12. So that's how I got that B was equal to 12, because we got to find all the missing side lengths. And you do the same thing for the rest of those, 1 through 7. Now, when you get to 8, 9, 10, and 11, you're going to try to find the lengths of AB. Well, just move this 30 in here so it looks better. You can move this 45 in here. Just have a little formatting error there. And, well, what do we know about this? We know this is a 30, 60, 90 triangle. We know this is a 45, 45, 90 triangle. And therefore, this is 30 and this is 45. And we should be able to solve the missing side length. So we're going to find AB. Well, what is AB? Well, if the short leg is 5, well, we really just got to go 5 times 2, and that would be 10. Okay. I'll do another one down here. Let's figure out like what YW is. Well, if the long leg is 4 root 3, that means the short leg is just remove the root 3, and that would be 4. Okay. ZY, you should be able to figure that out. ZX. Oh no, those aren't that bad, in my opinion. What do they say? Find missing lengths. That's okay, that's okay. Where does, gosh, did I throw that out? There's a really good piece to this homework. Huh. Well, I guess I made pictures for all of you. You're welcome. It's a lot easier now on this page. So the only thing wrong is the formatting, but hopefully you guys can live with that. All right, those are some good practice problems. So wish you the best of luck. You got to get to page 40.